So Vanessa, whenever you're ready, you can go ahead and upload or share your presentation and start. All right. We see your presentation. So whenever you're ready.
Okay. I'm ready now. Can you hear me?
Yes, I can.
Okay. All right. Greetings, everyone. My name is Vanessa Miller, and I will be presenting my capstone project, Assessing GIS Technologies for Site Selection and Monitoring in the Riparian Forest for Landowners program. So let me start off by saying that my background is primarily in hydrography, so this is not my background. However, I took this on as a GIS challenge. But in hydrography, I spent roughly about 20 years conducting hydrographic surveys and bathymetric analyses for the U.S. Navy and the National Oceanic and Atmospheric Administration. In 2022, I became a stay-at-home mom while enrolled at Penn State and transitioned to the broader spatial field of GIS. With that stated, this capstone project reflects a real-world case study of how GIS can be utilized as a practical solution to multidisciplinary paradoxes. And so my presentation will go as follows. I will introduce the topic, uh, discuss existing data, methodology, results, conclusion, and take questions. So let's transition on to the introduction. So, what is the Riparian Forest for Landowners Program, or RFFL? This is a state of Virginia funded program, which is not just for residential landowners, but also includes property owners in rural, urban, and suburban areas. Programs such as the RFFL exist to restore riparian forests and wetlands that have been diminished by urbanization and agricultural practices. These forested buffer zones filter pollution, stabilize floodplains, and sustain aquatic and wildlife habitats. In one brief statistic, it took nearly 50 years for the James River Association and partner programs to meet a 68% goal of restoring almost 10,000 miles of riparian forest and improving the water quality of the James River to an overall grade of B. So, in researching the RFL program, I discovered a key research gap. According to Scott Bachman of the Virginia Department of Forestry, the RFL program is not currently using remotely sensed technology to evaluate planting sites, and maximum site width is determined by conventional aerial photography. Another nuance is that the research uncovered that for legal purposes, under Virginia Code 58.1 TAC 3666, it is written to classify wetlands, living shorelines, and riparian buffers into the same category when considering land ownership and tax revenue. Thus, this capstone examined not only the feasibility for riparian forests in a riparian zone, but also riparian forests that are part of living shoreline features. From this information and an exploratory data analysis, I constructed the hypothesis that there are a few use cases for the RFL program in the Hampton Roads region, which is Virginia's second most largest region and the region with the most diverse shoreline types. From this, I divided my project into two parts. The first part being the feasibility study that identified whether GIS technologies could be used to categorize suitable sites. And the second portion of the project examined how to model and disseminate remotely sensed data to serve as a template for long-term monitoring to reduce the number of physical site visits for individuals participating in the RFL program. The caveats of this project are that the framework of the project is at the local scale and data sources are at a spatial resolution of zero point 0.6 to 10 meters, with the exception of the national land cover and the riparian buffer databases. The study conceptualizes an analyst or city official operating within an enterprise environment at the state or local level, performing basic to intermediate GIS analyses. And thus, more specialized tools such as eCognition, Envy, LMS Pro were not considered, were considered but not utilized. So just some definitions. The living shoreline, according to the Code of Virginia 28.2, TAC 104.1, defines a living shoreline as a shoreline management practice that provides erosion control and water quality benefits, whereas a riparian forest buffer can be defined as a linear wooded area of varying width near a water feature. And this buffer can also be part of a living shoreline and also connected to wetlands. Collectively, these elements form a riparian ecosystem or a complex assemblage of plants and other organisms in an environment adjacent to and near flowing water. So let's transition to the existing data review. Two of the primary sources that were used in the feasibility study were the riparian area of opportunity tool, where extracted areas of riparian opportunity greater than 50% were examined, as well as the Virginia Coastal Resources tool, which was used to extract shoreline inventories and shoreline management models. At the bottom of the slide, you can see the RAO, or the Riparian Area of Opportunity, which was derived to be the IMP times the percent cropland divided by 100, where the IMP is defined as a geospatial model that uses the hydrologic unit code or unique identifiers in the continental US to identify watersheds that are most important to surface drinking water, have the ability to produce clean water, forest ownership, and potential threats to water yield. So let me move on to the methodology and data sources. So this slide examines the methodology workflow for conducting A, the feasibility study, and B, the modeling study. Um, within the modeling study, NAPE imagery was obtained from the USGS Earth Explorer and also a stack image collection. LiDAR image was obtained from the 3-depth LiDAR Explorer. Items highlighted in red were introduced after the initial project proposal. So given the conceptual framework of this workflow being introduced to a local and state enterprise ArcGIS environment, the feasibility study is conducted and configured as a core GIS spatial analysis, deriving results from spatial joins, intersects, overlays, proximity-based techniques, rather than using statistical analyses such as Moran's 1 or LISA. The feasibility study focused on GIS analyses, which use the riparian area of opportunity, the shoreline management model, shoreline inventory, the National Riparian Buffer Zone, and the National Land Cover Database. The modeling portion focused on object-based analysis, which included image segmentation, creating and training samples, using both random tree ensemble methods and support vector machine algorithms. Now, although the SVM outperformed the random trees ensemble classifier method, neither method achieved an accuracy above 0.75. Thus, the project shifted toward exploring a pixel-based classification using a pre-trained deep learning model that uses the UNet architecture and boasted an overall classification accuracy of 86.5%. Now, although this accuracy is not acceptable for high integrity applications, it was considered suitable for rapid prototyping. Now, the final portion of this workflow includes the dissemination of data products, which was achieved using ArcGIS Instant App and Experience Builder. So now I'm transitioning to some of the visualizations of my results. So using method A1, a method that used a spatial analysis incorporating the shoreline inventory and shoreline management models, criteria were set to identify areas of the shoreline that were within a 50% or greater riparian area of opportunity indexed and at the 10-meter resolution. Um, these areas were extracted for defended shorelines, i.e., places along the shoreline that could be converted to living shorelines, areas, and also areas that were categorized as residential or forested by the shoreline management model. Now, of these set criteria, the only municipality within the Hampton Roads region that met these set criteria were in James City County. And of these segments that met this set criteria, only 264 meters, or roughly 23%, were characterized as undefined or maintain, enhance, or create marsh. Now, moving on to the methodology 2, which utilizes the natural land cover database raster model. This model was clipped to the area within the riparian forest, so riparian area of opportunity with the 50% or greater caveat, and it was vectorized for the analysis. The analysis examined areas of the NLCD with classification codes of 21, 81, and 82. In this method, Isle of Wight County, as seen on the top, and Surrey County in item B, showed the most favorable results, identifying approximately 5,363 and 3,248 acres, respectively, of cultivated cropland that could meet the criteria for a potential RFFL site. Now, transitioning to the second portion of the results, the modeling and dissemination. These examples presented in the following slides were intentional design choices intended to enable rapid product dissemination. So a temporal multidimensional raster product, or a NAEP of the NAEP NDVI indices, was created by altering the mosaic's image attributes and building the multidimensional information in ArcGIS Pro. Now moving on to the deep learning point cloud classification. Represented in this slide are the number one results for the deep learning point cloud classification tree model. Let me see if I can get that going. Let's see if it's gonna go. Is it gonna go? All right, let's see. All right, there it goes. My apologies. So it is the results of the deep learning point cloud classification of the tree canopy model, and then also it shows the point cloud data that was classified in LP 360 and edited in ArcGIS, ArcGIS Pro to include the added classification of wetlands. These data were converted to scenes and disseminated online using ArcGIS Experience Builder. Now let's look at the deep learning pixel land classification models. These slides show the results of 3 rasters. The first raster product being the change detection raster between the 2011 and 2023 NAEP images for a given subset of the area of interest. The second and third products are the deep learning land cover classification rasters for the 2023 and 2011 NAEP imagery, respectively. A swipe feature was added to allow the end users to visualize changes, and also a link to the accuracy model was added, and this links to a story map brief that explains how the accuracy assessment was conducted. So final accuracy for the 2011 deep learning classification model are presented here. The left slide shows the confusion matrix, and the right side of the slide shows the confusion matrix model report. The overall accuracy was concluded at 0.76, and the Cohen's kappa for this model was computed at 0.71. For the 2023 accuracy assessment, here are the same figures, with the overall accuracy being computed at 0.76 and the Cohen's kappa being computed at, I'm sorry, the overall accuracy being computed at 0.82 and the Cohen's kappa being computed at 0.800. So, in conclusion, the feasibility study shows and also supports the hypothesis that there were limited areas within the RFL program where the RFL program could be introduced in the Hampton Roads region. Now, based on the workflow and some of the modeling, if I could reconfigure this product and reconfigure this project and produce it again, I would start off by using a deep learning model trained using the NLCD schema, generate a thematic layer based on the deep learning model. I would introduce parcel data sets to differentiate among the land ownership types. I would set a criterion for land residential versus private. I would include sentiment analysis as a criteria. Um, I would create a buffer zone, examine the deep learning models again for class outcomes and spatial joins, and then include a buffer zone. I would then set the final exclusion criteria and scrutinize the results. So this slide represents a QR code that takes you to a story mapping briefing of my capstone references. And so I now have time for any questions. So let me stop sharing my screen here and look for any questions that pop up in the chat window.
All right, Vanessa, thanks so much for a great presentation. Since we're all here, have to apologize. I jumped the gun. I started our session 20 minutes sooner than what was scheduled. I don't know why we changed our start time to 11:50 today. Previous uh, Tuesday and Wednesday start times were 11:30, so I got that set in my head. So we're 20 minutes ahead of time. I
Okay.
mean, it's fine. Everyone's here. Just one of those senior moments I have increasingly.
It's quite all right. I was sitting in early just because I've been around for a little while and I know how those things can happen. So I
No,
was like,
it's completely on me. Like I said, Tuesday and Wednesday we start at 11:30. I just blanket copied that template over to start 11:30 today, but I looked at the schedule and it said 11:50 is when we're supposed to start. So yeah, I'm sorry we got out of sequence, but I guess that means we'll just finish up 20 minutes sooner than anticipated since we're all here.
okay, that's quite all right. I don't see any questions, so I guess we could just kind of move on.
Well, actually, I do have a question that I
Okay.
couldn't ask you through the paper, right? So the idea of this living shoreline, I guess there's two questions I have. One is what is the incentive of the landowner to do this? Or is there anything that the landowner needs to do? Is this just something that's assigned to them? Or explain to me how this thing works in the real world.
Okay, in the real world, the incentive is there is a percentage of land of your land that is not taxed if your land includes a riparian forest or a uh, living shoreline. So the incentive is basically how your land is taxed. So I wouldn't necessarily say tax revenue because your land is still taxed, but it is the percentage at which your land is taxed that is discounted. Um, Now, with respect to how it works, the program is actually free because it's funded through the U.S. DA as well as a state-funded Commonwealth Water Quality Fund. Um, and they come to they visit your land and they set up a riparian forest, or there's also a another program that establishes living shorelines. But the incentive for the state is that it helps maintain clean water within the Chesapeake Bay watershed or any other watershed within the state of Virginia.
So the taxation is, so if you have 1,000 acres or whatever, whatever percent of your land is designated as this living shoreline would be, let's say it's 3% of your shoreline. So that many acres would be taken out of your assessment then for your acreage for your taxation purposes. Is that the basic idea?
Yeah, that's correct.
Okay. And then if your shoreline has been identified as like through your methods here, has been identified as a possible candidate, the landowner would be contacted and then someone would come out and identify what the, BMPs would be for that stretch of shoreline.
No, they would not be contacted. So based on my brief conversation with the state officials from Virginia, uh the landowner themselves would have to find this program and contact the state of Virginia for this program to be implemented on their land.
So I guess I hate to be asked the I mean that this is important because implementation of ideas is pretty critical here. So um, how how could we I mean it's probably the case that not many landowners know about this program, for example.
That's correct. And the only reason why I even came across the program was because I was just looking for something to do, try to figure out how to manage the land or the property that I'm living on. And then I was just looking at random things and I found the program and I started contacting the state and asking, like, what are these programs and how would someone know? And the answer was basically you don't know unless you go out and look for that information. So the program is funded, and there are several other programs out there that are funded, but for many landowners within the region, they do not have a idea that funding is available and that funding is free, and also that they do have assistance to meet the legal criteria to convert their land to living shorelines, which was another legal criteria that was set in 2011, where the state of Virginia passed legislation that all shorelines within the state of Virginia must be changed to living shorelines unless otherwise stated by this shoreline management model. So, yeah, it's one of those things.
So to carry your idea, I know you're not necessarily, a policy person, but how could your project be disseminated to the people that or who then could let residents know that this thing is beneficial to both them and the environment?
One idea is that I could reach back out to the state of Virginia and let them know that, this is something that I've been researching. and that it is visual because one of the biggest things that I've found within my own area where I live around a lot of landowners who have either a living shoreline or defended shorelines and are looking for help, is that they need some type of visualization in order to understand some of the policies and procedures that have been enacted, not only locally, but also within the state. So, a lot of people are very visual and they do not understand just blanket policies. And so I think that having that visualization, and then including and incorporating other programs visually for landowners would also be extremely beneficial, not only for the state, but for different localities and property owners.
All right. Well, sorry to belabor the point here. I just find it fascinating that I used to live in Maryland, and there was a similar program in place for forests. It's called stewardship program, and the same issue was rampant there, is that people just didn't know about it, and there were financial incentives that came along with people that would adopt or join up with this program. So I find it interesting that the same kind of issue is present in another form, your shoreline question. Um, so, anyways, kind of moving forward here. Yeah, um, yeah, great job. Um, I think let's see, Madeline. I think you're scheduled to go next.
Can you hear me?
Yes, we can. So if you want to go ahead and share your screen, and then you can start whenever.
I was one of the people that got here just as we were going to start, so I missed Vanessa's presentation. I was actually looking forward to it because it's very related to my study in a lot of ways, because stakeholders that have properties that abut to the Veolia Water Company property or watershed, you know, don't treat their land very well. And I don't know of any programs here in New Jersey that are like the one that you just described now while Fritz was asking the question. So I think those presentations will be available to us. Or is Vanessa's presentation going to be available to us?
Yeah, so everyone's presentation is being recorded, and Beth King is the one who will slice and dice all of them up, and she'll post them some point in the near future. So yeah, you can go back and look at all the recordings. Yeah.
Yeah. So let me pull up my presentation here. I have so many screens, I'm not sure if. Okay. Can you see my screen? The use of GIS?
Yes.
Okay, good, good. All right. And can you see my cursor when I move it around in front or no?
Yeah, but that's not it's no big deal.
Okay. Okay, just curious. All right. And let me move this because you are in my screen. Oh, all right. So I'm here today to present to you the study that I did for my capstone. It's the use of GIS tools to identify water quality sensor sites and best management practices opportunities in the New Jersey Hackensack River watershed. Oh, let me see. There we go. I just had to click on the screen. So, I'll be going over an introduction, the project site information, goals and objectives, the previous research that's been done, data and methodology that I use, my results, discussion and conclusion, and also the references. And then at the end, we'll go over questions. So, I am a certified arborist, forester, utility vegetation management professional, and I recently switched over to watershed supervisor position for a water company, learning that over at Veolia Water Treatment Plant, we treat 98 million gallons of water per day for our customers. And one of the things that the company has been using for years is copper sulfate to address harmful algal blooms. The harmful algal blooms come from excess amount of nutrients going into the water. So this copper sulfate is no longer ecologically sustainable. It creates problems. It basically kills the ecology of the water system. And so we're using more holistic approaches or ecological approaches to try to manage the water and have it clean at the source before it actually goes into the plant. In this study, I'm conducting a GIS-based spatial analysis to identify high-risk pollutant pathways and prioritize the monitoring sites, and also identify best management practices sites so that we can protect the water before getting to the plant. So here's a study site. You can see it's New York and New Jersey on the right. It starts up at Lake DeForest up at the top, the northern part, and then it falls into Lake Tapan, which is right on the border between New York and New Jersey. And then over to the west, there's Woodcliff Lake, which is a little bit smaller. It is a very deep lake. And then that all pours into the Oradell Reservoir, which is where our plant is. We manage the total watershed area is about 72,000 acres. Veolia manages about 4,100 acres. And we have the total raw water storage capacity of 14 billion gallons. And we have active strategies that we use on a daily basis to manage the watershed: data collection, processing, and validation, wildlife management, which I just had to move my cat over, forestry management, ecological conservation, and then engaging the community. So what we do is, basically, we're trying to use best management practices to try to address the non-point source pollution, and it's going all the way from the land into the water. On the left here is a deer exclusion fence that we put in an area on property to keep the deer out, so that they don't eat up the understory. There's live staking for riverbank restoration, putting clippings of trees in the area into the riverbanks so that we create, we prevent erosion that then increases the nutrients that go into the water. We do biochar remediation. These bags here, we just pulled them up a couple of weeks ago. We put them in the water in effluent areas and they pick up excess nutrients, and then we do an analysis. And then we also have the floating wetland islands, which basically the vegetation roots pick up excess nutrients from the water column. Okay, here are the project goals. So what I wanted to do is import the feature layers that are important, the water companies, a series of them, the abutting parcels, a golf course polygons that were created, as well as best management practices, and eventually sensor points. I obtained the DEM to conduct a hydrology spatial analysis of the watershed and create watersheds, obtaining the raster layers that are going to let us know, where those high risk areas are so that we can prioritize, and then the final analysis of understanding how these three rosters impact the water. So here's my project objective. We wanted to identify and prioritize the sensor locations where we're going to detect water quality. And then we're going to use GIS analyses to identify the surface runoff pathways with that DM layer. and hydrology tool, and understand the water that goes from the subcatchment areas all the way to the water bodies, the lakes and the reservoirs. Expected results is recommended sensor locations are going to be directly related to the major contributors of non-point source pollution, and that's probably going to be the developed lands, impervious soils, low canopy cover, and golf course areas. So previous research that was done here, Dabrowska and their team, they did a study of the lower basin, and they focus on agricultural areas. I used some of their ideas for the watershed, and since my study area is mostly man-made lakes, reservoirs that change water levels significantly based on the need for water from the community, I have a different approach. It's definitely not agriculture. It's impervious surfaces, riparian, minimal riparian buffers, and then forest densities, as well as soils. Another thing that I brought into this study was the golf course study that was done by Bach and his team, and they found that approximately 2 to 20 kilograms per hectare per year of nitrogen are released from golf courses, and 0.1 to 1 kilograms per hectare per year of phosphorus, which is a significant amount of nutrients. And then riparian zones are a big concern, or something that we need to take into consideration. Cole and his team studied that at least a 300-foot buffer would be best to filter water prior to it going into a water body, and so that's something that will be addressed in this study. Here are two other research that was done. Harrison and his team came up with how deer browsing affects the nutrient uptake of the area. One of the things that the water company recently did in 2025, this year, we conducted unmanned aerial systems, SUAS, infrared study on the deer density of the area, and we found that on average there are 41 deer per square mile, and the recommended density is about 11 to 14 deer per square mile. So if you look at the picture, to the left of the picture, there's a lot of vegetation on the ground. You can probably see smaller trees that are starting to grow for the future forest. And then on the right side, you'll see that the bare soil is exposed. And if you were to zero in there, you'd see the roots exposed. As more roots are exposed, the trees cannot uptake water and nutrients. So you have an increased amount of runoff. And then on the right-hand side, Santos and their team did a study on riverine landscapes and how it impacts diversity. So a continuous landscape is important for pollinator and bee species diversity. So here's the data that I used. We had the Veolia parcels, the DEMs, and you'll be able to see the images in a minute here, the land cover and tree canopy, and the soil hydrologic groups and what they were used for. We've got here the digital elevation models. I had 6, 2 in New York and 4 in New Jersey, and I had to mosaic them and reproject them to the datum that to the NAD 1983 UTM Zone 18N, which was the best ones to use for the area since it was local, and then the datum and projections across my rosters and my layers to be uniform and the same. Then you can look here, the Veolia property and abutting parcel layers are there. We've got the next 3 layers are the ones that we were going to intersect. So this is the U.S. National Land Cover data set. And the main thing to focus here is you see all the red, which all the red is the developed land from light pink all the way to dark pink. The dark pink is the high developed. The light pink is the low developed. And this layer, I separated out the developed areas. So that was a layer that I wanted to focus on. Anything that was developed I wanted to identify in this study. With the tree canopy, what I wanted to understand and study and create a layer for was anything less than 50%. There was a study done that greater than 30% of tree canopy is gonna benefit humanity as well as the natural environment. So I wanted to go over that 25%. So I chose anything below 50%. Created a layer for that. And then finally, the U.S. Soil Hydrologic Group. This is the soils and how much water they retain. Everything you see that's gray and yellow are group C, D, or CD. These are soils that are impermeable, very clay soils, and they tend to not percolate any water. So I created a layer including those three, and so that gave me the three layers that where if they intersected, that you were going to have the highest amount of runoff. I'll show you in the next slide. This is still part of the methodology. I'm not going to go into detail about this because you'll get to see the images, but the DEM and hydrology was one of the first things I did, and the 8-node algorithm was used, D8 was used, which is one that gives you more accurate flow accumulator. To understand the flow in the riverines, and then the land use using the NLCD raster and creating the layers that I wanted there. The soil hydrology also was derived so that I can get all those classes of soils, and then the site prioritization is the intersect of all of these. So here's the DEM. I know, Fritz, you gave some great feedback on this, and it was really hard for me to make it a little lighter, darker, playing with the colors. But basically what you see here is the darker colors have about 0 to 30,000 cells in the area, meaning that there's no flow, less flow. Anything greater than 30,000, there was a significant amount of flow, which basically told me that there was, stream networks there. So those are the stream networks. This is an example of the Oradell reservoir. So you can see all the riverines that are going into the Oradell. And then here are the overlays. So once I conducted the intersect, like I mentioned before, I created an impermeable soil layer with CD, and then the CD combination, developed layer with all the layers that were developed from low to high, and anything less than 50% was a low canopy layer. And then when I did an intersect for those, it gave me these high risk areas here in red, and then you'll notice there's a purple dots or lines, monitor site intersects, which were the 52 linear high risk segments that intersected those high risk areas. When I dove into those areas and wanted to really understand, what we found here, I got the sensor monitor sites created. I created a feature class for that. And I created layers for the best management practices sites for on company property and non. So the hash marked gray areas are company property, and the gray, just solid gray areas are non-company property. In this one, you can see that, the purple lines are going through company property mostly, and down at the bottom, you can see that there's that point feature of the sensor monitoring site right there where it delivers the water right into the reservoir. This is actually Lake Tapan. And so, this is an ideal area for the study because, we can actually apply best management practices here and don't have to depend on non-company property. And then the second challenge here was you can see that, there's company property up the upper part of the map where the hash marks are, and then non-company property at the bottom, and they're both intersected by tributaries that meet over to the right-hand side in the deeper riverine area. And you can, this is one where, if I were to put the sensor up at the top by the company property, I wouldn't be able to measure, what else is coming into our reservoir from a non-company property. And, we can take some measurements there and see as they go down if as we start using best management practices on our property. And then, here's another challenge that I had, the tributaries stemming from a different property or non-company property. And then right at the end on the left-hand side, you can see where that long purple line ends. I did some field reviews, looked at the site, and if we were to put a sensor there, it would be a little challenging because the water gets pretty low. Wouldn't be able to put a sensor there. So I chose to put a sensor close to the reservoir down at the bottom. It's a long ways there. The water travels, and it's also being intersected by another water body from the north. So, that was the ideal location there due to the geography of where it recommended to put the monitor site. And then here we have the BMP site selection that we did. So we intersected the high-risk areas of company-owned property, and we got 105 polygon sites. I labeled them BMP sites company-owned, so we know those are areas that we can address. The Oradell and Lake Tapan had the most, with Oradell having 50 polygons and Lake Tapan 40. Woodcliff Lake only had 8. So it looks like, these are the areas that need the most support based on how much runoff they're going to get. I also included the sensor sites here, and you'll notice like that the BMP sites correlate with the sensor monitoring sites. So you'll see that all of them have tributaries just north of them that are going to be impacted by the runoff from these high-risk areas. I also created a histogram of acres and found that all those polygons that were created on average are 1/10 of an acre, so they're fragmented throughout the property. And there's been a lot of studies on fragmentation. If we're able to create best management practices and habitat or riparian, converted into a riparian area, we'll have not only a significant impact on water quality, but also an increase in biodiversity and species conservation. And then, this is just a little slide on the golf courses. So I actually created the polygons of the golf courses myself. There's 10 that were identified. 9 have tributaries that directly lead to the reservoirs. 6 of the golf courses were on the Oradell on the south there. And then 4 were on Lake Tapan. Woodcliff Lake has none, so that's a good thing. Each golf course was given a unique name and associated with the sensor where the water is delivered from the golf course to the water bodies or to the reservoirs and lakes. And then here are my results. So we had 52 linear sites that were identified as high risk, and 31 sensor sites were created. 105 polygons came about that are ideal best management practices sites, with a total of almost 6 acres that we can work on. High risk zones were identified correlated with developed land, low canopy, and high runoff soils. And then, the nitrogen loss of golf courses is from the acreage converted to hectares that I got from the analysis. Nitrogen loss is about 1,900 kilograms per hectare per year. And then the phosphorus loss is about 94 kilograms per hectare per year. And then finally, the sensor placement strategy and BMP prioritization is now available, and we're able to use it. And you can see in this map here to the right, there's, I hadn't showed one of these before, but this shows the complete watershed and then the subcatchments of the watershed. So DeForest is up at the top, and then Tapan is orange right in the center. Woodcliff is to the left and it's green, and then Oradell is down at the bottom there. And then my conclusion is we got 31 priority water quality sensor locations that we can maybe put into place as a company to start monitoring. We've got the BMPs delineated, the best managed practices sites delineated, so that we can focus on those locations. One thing that we can consider is working with the golf courses and come up with some management agreements so that we can reduce the amount of nitrogen and phosphorus going into the area. Deer browsing is a problem, and we can address it with fence exclusion and vegetation restoration. We can use the sites that were identified to do something like this. And we also got the recommended BMPs, which is the soil decompaction, live staking, removing invasive species, and planting with natives, and then the floating islands for wetland uptake. And these are my references. I had a lot of references. And that's it. Thank you. Anybody have any questions?
All right, Madeline, thanks. Great job.
Thank you.
Have I guess, a question for implementation purposes. So you said you identified 31 sensor locations. What kind of, I guess, they're not free, right? Each sensor has a price tag with it, and then the installation and monitoring and so forth, so on and so forth. So I'm kind of making the assumption that you can't afford to do all 31 sensor locations. So how could you prioritize which sensor sites get selected, and how would that process unfold?
Yeah, that's a great question. And yeah, they're super expensive. It depends on what approach you want to take. So one thing that we can do, so one sensor averages anywhere from 2,000 to 15,000 per sensor. So it's expensive. But in the end, we can put ourselves on a 5-year plan to start, start with a percentage of them. Maybe like we'll start with 10 and work our way there. One thing that we can do, the ones that are least critical, we can, instead of using like an actual sensor, we can do water quality testing, like, on a monthly basis, or maybe once a year, rather than continuously monitoring it. And make it statistically sound, right? So that's something that maybe we can do, or maybe a combination of those. So maybe we can start looking at all of them, do the 10 the first year, and the rest we can do where we go on site. And then the next year we add another 10. And then the third year we add the last 10. And, we still collect some data. So I'm the land person on my team, and we have the water person on our team, and we do have 2 sensors per water body on site. And that's one of the things I want to do. We've already talked about how we're going to go about this, but I want to collaborate with them on this. And when I publish the paper, I would like to publish it together with them, so we have the holistic approach there. But I'll be able to get the data from what they get and include it in this, and then continue to research it for the next 5 to 10 years and see how things change through time.
All right. Well, thanks for your response, and best of luck with the project.
Thank you. Anybody else? We're good?
Well, hold on. Let's see. I think there may be another question here. There is a question in the chat window.
Oh, how do I see that? Here we go. All right. Very persuasive. Are you going to present this to decision makers, like within my company? Oops. Is that what you mean with that question? Was Greg?
Yes.
What did he say? Oh, okay. Yeah. So within the company, we do have support. So, Veolia, the motto is that, we're creating ecological transformation. And that's basically what the company is about. And so this watershed team was created 3 years ago, because the company, they made a case that it was important to actually have dedicated professionals that know the ecology and the watershed ecosystem and how it works, and how we can use alternative approaches rather than, copper sulfate, or not even paying attention to the riparian riparian forests. So the team was created and it's growing. And I can envision there's a lot of interest. Veolia is huge. It's international. The original company is from France, from Paris, France, and the word has gotten around on the different things that we're doing. And we're basically creating a model for the company. We're getting support. And I think that if we approach it, like I said, in like a 3-year period, or like come up with a plan, and present it the right way, I know that they'll be supportive about it.
All right.
Thanks, Greg.
Yep. Yep. Thanks, Greg. So go ahead and stop
Right.
sharing your screen, and Zorka, if you
And
want to
do
go.
that.
There
All
you
right.
go.
Thank you, everyone.
Yeah, Zorka, if you want to go ahead and start sharing your screen.
Um, Hello. Hi. Can you see my screen?
No.
Mm. Now?
Yes.
Hi, my name is Zoritza Penman, and I'm here today to present my Capstone project on geo-enhanced social network analysis framework for anti-money laundering detection. This project explores how the social network analysis in geospatial context can enhance the anti-money laundering investigations. Since traditional AML systems focus only on individual transactions and rules, they often result in high false positives and miss the complex schemes. My goal with this project was to demonstrate by using synthetic data how a network-based and geographic approach can reveal the laundering structures that are invisible just by looking in tabular data. The money laundering is often costly and complex, involving different placements, layering, and integration. And most current systems rely on thresholds and rules like how big the transaction size is, like under 10,000, or frequency, which detect obvious cases but fail against the sophisticated networks. And often these systems overwhelm the analysts and provide false alerts. On top of that, the real transaction data is highly restricted, which makes it difficult to develop or test advanced analytical methods. The motivation for this project is like when the analyst is coming with like very big Excel data and just looks in millions of records, it's really hard to see if there's any issues or problems with it. And modern laundering operates through coordinated networks and accounts, often across borders. So when we use to look at the transactions individually, we often miss how accounts interact as a system. The social network analysis lets us focus on the relationships between multiple accounts and not just the amount. By adding geography and governance context into this dashboard that I built would further help explain why certain flows are risky, especially when they involve weak regulatory systems. Some previous research for AML detection shows that there are some other people who thought of doing the same process because social network analysis is effective in identifying the hidden and influential actors within criminal and financial networks. By adding the spatial and the temporal patterns matters because criminal activity is not randomly distributed, but often exhibits clear geographic and temporal clustering. By mapping the financial transactions geographically, this project aligns with the evidence that spatial patterns improve the detection accuracy and provide meaningful insights into how illicit activity concentrates across jurisdictions.
I used a synthetic data set, the money laundering data set that was published on Kaggle and has more than 9 million transactions and offers some data, different typologies for, and it has also in the data which accounts are flagged as suspicious. I use fields like the sender and receiver accounts, the transaction amounts, from which country to which country was the money sent, and timestamps. By building a dashboard, I used Python and I added some global sidebars so the analyst can filter by time, topology, geography. Then I added multiple analytical views and I organized it in tab. To map the account interactions into social network analysis, I used some Python packages like NetworkX, Pandas, Matplotlib, and Folium. And with this, I was able to build the network construction and centrality measures. The key centrality measures that were used were degree centrality that identifies the major transaction hubs between these different accounts. Between centrality is another measurement that finds the intermediaries through which the money flows. Eigenvector centrality usually locates the most influential nodes into the network. I included not just like a static picture from the dashboard that was built, but also a video so you can kind of walk through with me through the dashboard. These are the different accounts that kind of, when you open the dashboard, like in the data is floating in, you can see like which accounts are most obviously clustering. On the side, you can see that there's a transaction rate range, so you the analyst can filter through specific dates, or it can choose different laundering types. Also, you can select or unselect through the different countries. So you can extract for like the ones that you're interested in. This gives kind of like the overall, just a picture of like the transaction corridors and by governance indicators. You can zoom in on like which countries have the most hotspots, and with the last one, with the World Bank indicators, which shows only the countries that are involved in the filter transactions. You can see which countries have like higher or lower rule of law, regular equality. So you can kind of base the background, these indicators don't really prove wrongdoing, but they help contextualize the risk and give context to the analysis. So when suspicious flows consistently involve countries with weaker governance, it supports prioritization and investigative focus towards that place. Also, when money flows, this is like a folio map transaction, which is aggregated by sender and receiver country, helps give like the hotspot detection, and they are aggregated by sender and receiver country and visualized as geographic flows. It reveals patterns as concentrated outbound activity, asymmetric corridors, or repeated cross-border paths. Many laundering topologies rely on jurisdiction hopping, so visualization country-to-country flows adds critical context that network metrics alone can provide. This is the governance indicators that I kind of gave for overview already. Across different filters, suspicious topologies tend to form distinct network structures like hubs, chains, and cycles. Accounts involved in laundering often rank highly in centrality measures, and geographic flows frequently highlight cross-border layering. So the government's indicators provide additional explanations for why certain routes appear repeatedly. Together, these views reinforce each other and align with well-known anti-money laundering research findings. Some of the limitations for this project was that it's hard to find real data to test the dashboard with, but this synthetic data enables realistic experimentation without privacy risk. However, this approach is research and mostly demonstration tool, not an operational system yet, and governance indicators are necessarily at a high level. But overall, shifting the analytical focus from individual transactions to network and behavior patterns can reduce the false positive and expose the complex laundering structures that rule-based systems miss. In general, I'm really happy of how the project came around because it started from me taking a Python class with Penn State, and then the class I took for cyber and network development, social network analysis, which was gave me the idea to test it on anti-money laundering. Before that, I've only built some social network analysis for social media, and I was really surprised to find how quickly and so much more easily you can find the networks, and especially like the layering and the different kinds of ways it shows to the analyst and provides a foundation for the future anti-money laundering research and development. So hopefully it will be used soon. Thank you.
All right, Zorka, thank you very much. That's a really neat dashboard you created. There's 2 questions in the chat window, so if you could read those and respond, that'd be great.
This can be a great investigative tool. You indicated that you use synthetic data to create your dashboard. Will you be able to import banking currency transaction reports and suspicious activity reports? At work, if this is for financial institutions, yes, I would offer it. But at work, we can use like by tracking like some illegal transactions, and I would like to test it. I've used the code itself. Sorry, my dogs are in the background, but it's hard for like in a secure network to deploy the dashboard, so it has to go through a certain process. But I would like to offer it for them to use it because it's so much easier by having it all in one dashboard instead of, as an analyst, I know you have to go through like many different tools in order to get an answer. So I would hope so, yes. And the next question is, great work and very interesting interactive models. Are your applications hosted in Streamlit? Yes, when I was building the dashboard, I deployed it in Streamlit, and I would like to be able to deploy it on at work, but like I said, I have to go through the specific office. Are your hotspots able to zoom into specific cities or even banking locations? So the data set that I used only had country codes, but if it all depends on the data it comes. So if the data comes with like a Latin long, it will be able to zoom in on a city or a thing. just for the purpose of creating this dashboard, I used the country codes. So it was able to geocode, and I connected it to the API from World Bank data indicators. So they were able to connect. So whenever a country shows in the data set, it will pull from that API for that, and it gives the government's index for that country. But yes, if the data set comes with Latin long for specific city, it will pull on that data for that city, and it will be able to zoom in on in volume.
All right, Zorka, thanks for the responses. And again, great job with the presentation.
Thank you.
Next, we have our final presenter, Jeff. If you want to go ahead and start sharing your screen.
Hello, good afternoon. Just want to double check you can hear me.
Yes.
Okay, great. Let me see here. Everybody can see my, yes. Looks like it. Okay. Get the windows situated here.
All
All right, good afternoon. I'm Jeff Hall. Can you see my screen? Sorry.
Yeah, that was.
Can you hear me?
Tell you, so go ahead.
Okay. Good afternoon. I'm Jeff Hall. I'm currently a GIS analyst at NAVFAC Washington. I'm a Masters of GIS candidate this December, and I also completed the graduate certificate in GIS program and web development in 2024. And federal geospatial work, along with public works. I have a background in applied GIS data visualization and operational mapping. Today, I'm going to be talking about my capstone project, FlyMap, which is an acronym for Functional Landfly Mapping and Awareness Prototype. This project serves as a user-centered design principles can be applied to improve public-facing web map and tools for spotted lanternfly awareness and reporting in Maryland. Rather than focusing on predictive modeling and advanced analytics, the project emphasizes clarity, interpretability, and spatial communication for non-technical users. The emphasis is on experience with real users and real constraints. This is a design-focused GIS capstone, not a modeling project. My project is motivated by public-facing GIS clarity gaps. So some of the contents of my presentation today, I will be going over. So why this project? Well, as a employee of my projects that I work on, I'm not able to use for this class, so I was looking for a capstone, and spotted lanternfly was a big topic of discussion throughout the area where I live in Maryland. And so I got to thinking about this project here. Spotted lanternfly continues to spread across the eastern U.S. Public awareness and reporting are critical to response efforts. Existing platforms are authoritative, but not always intuitive. The problem is not a lack of data, but how it's communicated. Non-technical users rely heavily on maps to understand risks. So the problem, spotted lanternfly poses ecological and economic risk. Public awareness and reporting are essential. There's a lot of fragmentation with the workflows on the existing platforms that are out there regarding spotted lanternfly. Maps do exist, but interpretation is unclear or basic, and the user interfaces are kind of stacked. You have to click through multiple menu options to get to the mapping products. This project does not critique scientific quality as far as it goes to the existing Cornell integrated pest management spotted lanternfly reference platform that this project evaluated. Since its detection in 2014, spotted lanternfly has spread rapidly and impacted agriculture, forestry, and residential landscapes. Public awareness and timely reporting are critical components of response strategies, which has made web-based mapping tools increasingly important. For these tools to be effective, users need to be able to quickly interpret risk proximity and regulatory status based on locations. So previous research regarding spotted lanternfly monitoring and GIS. Here's some of the studies that have been done. Research on spotted lanternfly consistently emphasizes its rapid spread, broad host range, agriculture, and forested systems. This work clearly establishes the importance of timely detection, public reporting, and accessible monitoring tools. As a result, mapping platforms have become central component of spotted lanternfly response strategies. At the same time, WebGIS and geovisualization research consistently shows that public-facing maps often prioritize data availability over user understanding. Even when platforms are technically usable, users may struggle to interpret proximity change over time or risk. Human-centered design research demonstrates that focusing on needs and interpretability can significantly improve engagement and decision relevance. Combine this literature reveals a gap between the availability of high-quality spotted lanternfly data and how effectively that data is communicated to the public. While platforms like the Cornell IPM system are generally usable, research suggests that usability alone does not guarantee clear interpretation. It directly addresses that gap by applying user-centered design principles to spotted lanternfly awareness mapping. So the existing platform I've been discussing, there are a few out there. The main one I focused on was Cornell's Integrated Pest Management Spotted Lanternfly Web Map System. It serves as a national reference for identification and life cycles education and public reporting, is scientifically sound and widely trusted. However, its mapping components are embedded within a larger web page, often requiring users to navigate across multiple pages, location-based questions. This structure can increase interpretive effort, particularly for users seeking quick awareness rather than in-depth education. So taking a look at this right here, this is page. This is the landing page for that. And you have to go to one of these menus over here to the right or over here to the left to actually get to the interactive map. And once you get to the web, it's basically counties in a list. There's much more functionality to the website. So the let's see. So my identified gap, sorry, going backwards here. Beyond the research, usability matters outside of academics, determining whether tools are actually used, not just published. It impacts public trust, reporting, participation, and compliance. Poor usability increases training burden and adoption. And in practice, agencies prioritize tools that are clear, fast, and defensible. Stakeholders often abandon tools that are technically correct but confusing, and usability directly affects policy awareness and response outcomes. So the goal of this capstone was to explore how a map-focused user-centered interface could complement existing platforms by improving interpretability and engagement. Project intentionally limits scope to awareness and exploratory visualization. It does not perform spatial analysis, predictive modeling, or operational decision support to a degree at this point. The scope choice was made to preserve usability, integrity, and alignment between functionality. So the data and methodology for this project, I brought in some existing layers as we layer. I got map information and CSVs from the Department of Agriculture quarantine data. And then I also got spotted lanternfly and host species observations like the Tree of Heaven from iNaturalist, which is a crowdsourcing reporting website. And then I converted those into a data layer. Methodology, it's a user-centered design framework for the project. I also created an online survey using Esri Survey 123, and then expert informed evaluation and literature guidance help guide this project. Combining those user survey, expert review, and design iterations, the survey measured perceptions of the Cornell spotted lanternfly map. Results informed my prototype design decisions. The goal wasn't to make a more complex map, it was to make a more understandable one. The design helps to ensure that map supports decision users actually want to make. How the user-centered design informed map first layout to preserve my spatial context. I also have progressive drop-down menus to avoid overwhelming users, using clear symbology and labeling to support rapid interpretation, and separation of exploration, learning, and reporting workflows. So I also used system usability scale. What is system usability scale? This slide just gives a little bit about what it is. Design decisions emphasized immediate interpretability. I have unique value county symbology, allows users to quickly distinguish between quarantine areas, confirm infest, and reported sightings without relying or interaction or prior GIS knowledge. So why was system usability scale used? It provides a validated comparable usability metric. It's appropriate for small sample sizes and frequently used in GIS and web mapping applications evaluations. System usability study 68 is commonly cited as the threshold for acceptable usability. And then here's the additional numbers for that. Here are some example questions that were in the survey for the users. It doesn't measure correctness or analytical power. It measures how usable the system feels for real users. That distinction matters for public-facing GIS tools like this one. So for the survey, I got a total of 16 respondents. It included general public, government agency employees, and agricultural stakeholders such as vineyards. And then, of course, the questions had the system usability scale for the Cornell IPM spotted lanternfly map. And then people listed or decided which information needs and priorities they had. So results, the usability findings, the Cornell spotted lanternfly map sus score was 74.5 for the mean, which is above the accepted usability benchmark of 68. I received generally positive perceptions. That was one of the challenges I had with this project is partly how I structured the questions in my initial survey. They were lean towards positive, and I think I was expecting more of a negative feedback or critical feedback on navigation and use and available information, and generally positive. However, the key result is that even though positive usability was seen, it doesn't mean there's an optimal understanding. Users still wanted proximity, timing, and regulatory clarity. Interpretation gaps persist despite the usability of that website. Usability is not the main problem. Interpretation and context are. There was an opportunity for focused map first design. For the fly map prototype, I used a map first experience builder application, consolidates awareness, context, and reporting, and designed it to address identified gaps. In the image there, that is the main landing for the fly map. And in there I have accordion resources for Maryland Department of also discussion about what the map shows, using intuitive color shading for the counties showing the quarantine boundaries and a easily visible layer legend for users. And then in the middle, there's a reporting button. I have a lot of other things I want to do with this application due to the time allotted for the experience. I wasn't, it's not ambitious as I've liked. However, I'm pleased with how it turned out there. This is just another close-up of it with the spotted lanternfly observations generated on the map from the iNaturalist website. And then Maryland Department of Agricultural drop-down information. Some design decisions. I've kind of covered a lot of that previously. I'm not going to go through the entire story. So limitations and future work, exploratory scope and small sample. This project was limited to awareness with exploratory visualization, and the sample size was modest with limited agricultural stakeholder participation. Despite these limitations, the findings provide a defensible foundation for prototype development. Future work can include near real-time reporting, analytics dashboards, mitigation tracking, expanded usability testing with agricultural stakeholders. Overall, this capstone demonstrates that effective spotted lanternfly mapping does not require radical design, but integration of spatial, temporal, and contextual information aligning with user priorities. Usable maps can still be improved. User-centered design improves understanding, and thoughtful design as much as. Thank you. Are there any questions?
All right, Jeff, thanks a lot for your presentation.
Thank you.
Real nice experience builder application design.
Thank you.
So while we're waiting for a question or two in the chat window, what do you think would be, I mean, you know, the proverbial question, if you could go back and do it all over again, what would be one of the big changes you would like to make?
I think I would like to get out ahead of it earlier if I had the idea, now that I know the idea that I had, and maybe have more of an analysis proportion or portion of it as far as a statistical analysis for outbreak areas or potential areas for spread. You know, I'd like to do a analysis on corridors, like transportation corridors, and see how that can potentially do a network analysis and show the spread through transportation high-risk corridors, and how we could centralize mitigation efforts such as spotted lanternfly sniffing dogs that can smell out their eggs and they can detect it. I saw an interesting news segment on that a few months back, so that would be really interesting.
Yeah, that is interesting. Looks like you have a question in the chat window.
I can't see the chat, so hold on a second.
You have to get out of your, or stop sharing.
All right.
And I think you'll be able to see it then.
Okay. Are your hotspots able to zoom into specific? Oh, that's the wrong one. How many people tested the app? Was there a specific group of people? Unfortunately, I sent it out to like 35 vineyards and wineries because it actually grape production is affected by spotted lanternfly. And I read that Maryland has quite a bit of vineyards and wineries that could be affected by this. And so I was trying to get an agricultural sample. I also sent it out to general public to over 1,000 people. I only got 16 responses, so it was a smaller sample size. So it's, I guess what I'm trying to say is it's more of an awareness than an analysis as far as the sample size goes at this point.
And you have
Let's see.
more questions, right?
Yes, can this dashboard be scaled up and applied to other states? Yes, that is the intent, to scale it up so it can expand to all areas that are potentially affected by the spotted lanternfly. Initially, I went at the Mid-Atlantic. However, for the for the class, I focused in on Maryland as a test location sample study. However, the data and layers can support a scale up to other areas. Thank you.
All right. Thanks, Jeff, for your responses. And I want to thank all of you for giving your presentations. Great job to everybody. And I wish you big congratulations on getting through the course. I know it was a big slog for, for the purpose, but great job. I hope everyone can have a little time over the next few weeks to sort of decompress a bit and relax. Um, And then, yeah, I guess that's pretty much it for the day. Thanks again, and enjoy the rest of the semester.
Thank you.
Thanks, Fritz. Thanks, everyone.
Thank you.
Bye.